Business Cal, topic 1.4, number 36. How long to the nearest year will it take to become a millionaire if $1,000 is invested at 10% interest compounded continuously? Alright, if something's compounded continuously, we use the compounded continuously formula. And let's see, that'll be A equals the principal times e to the power of r t. Okay, and it says that we are starting off with $1,000 investment. That's called the principal. So this will be the principal. We also know that, let's see, let's move that over a little bit. We also know that E is a constant and the rate is going to be 10%. So, and the time is unknown. Now when we're trying to become a millionaire, well, to become a millionaire, we simply write in 1 million as the amount that we're going for. Alright, then we're going to solve for the time. So it's going to be 3 steps. Getting rid of the 1,000, the E, and the 10%. So first 1,000, we get rid of that by dividing both sides by 1,000. And that'll give us 1,000 equals e to the 0.10t. Next, getting rid of the e. We're going to convert this into a logarithm. So this will be log base e of 1,000, and that's going to equal 0.10t. Lastly, to get rid of the 0.10, we're going to divide both sides by 0.10. And that will give us our time. Let's see. So let's put that in there. So we need the natural log, ln, of 1,000, close parenthesis, divide that by 0.10, and we get 69 years. So 69 years, 1,000 will become a million at 10% interest. Okay, number 38. If an investment is losing its value, it's half its value every 2 years, find the associated decay rate. Well, if there's a decay rate, the formula that we use for that is the same as the continuous, because the continuous has a rate right there. Alright, so we'll go again with A equals P R e to the power of part t. And we're going to need some points. Let's see, maybe not. An investment is losing half its value every 2 years. Okay, so we have, let's see, the amount at the first, when we first start off, so that's times 0, the amount will be P. And then 2 years later, the output will be half of P. Okay. So it means that we can use, okay, so we're going from P to half of P. So P is here, and we're going down to half of P later. This will still be E. The rate we're looking for, we don't know that rate. But we know it's going to happen in 2 years, so t will be 2. Okay, so everything's placed in. So now we have to solve for the r. So it's going to take about 3 steps. We're going to get rid of the p, the e, and then the 2. To get rid of the p, we're going to divide both sides by p. And that'll give us 1/2 equals e to the r times 2. Next, we'll get rid of the e by converting this to a logarithm. So this will be natural log, which is base e, of 1/2 equals r times 2. The third step will be getting rid of the 2. So we're going to divide both sides by 2. So the rate will be the natural log of 1/2. So let's clear that. Natural log of 1 divided by 2. Okay. And then all divided by 2. And our rate is a negative 0.34, and that's 6, I'm going to round up to 7. or I can say a negative 34.7% rate. Oh, that's the associated decay. All right, number 57. 57. After taking aspirin, 300 millibytes, I guess, is absorbed. After the amount decays exponentially, with half being removed every 2 hours. Find the time needed to reach 1,000 millibytes of absorption. Okay, let's see. Since this is decaying exponentially, we'll have a general form of y equals a to the bx. And so we're going to need points for that model. And we know that the output of this is going to be the amount absorbed. So that's going to be the output. So 300. And we want to reach 100. I'm sorry, no. It says the amount decays by half. So it's going to go from 300 to 150. So that's my other point. All right, so got half there. Now, the input is going to be time. We know we're starting off at time 0, and then 2 hours later is when we finally get the 150. So let's start with this here. So 0 for the x and 300 for the y. A, b to the 0. Okay, b to the 0 is 1. So this means that a equals 300. And back over here, y is now 150. A is 300. B is b. And x is 2. So we'll divide both sides by 300. And what we'll get is a half here. And b squared is a half. Now I'll take the square root of both sides. And we have b equals the square root of 2. Alright, so what we have here is a formula. In fact, I'm going to use B for, let's use A for aspirin, and T for time. So aspirin is going to equal A, which is 300, and B, which is the square root of 1/2, all to the power of the time. Okay, and we want to know, see what happens when we get to, what does it take to reach 100? So the time that it takes to reach 100. So 100 here, and 300 there, and the square root of 1/2 there, and t. This is going to take about at least 2 steps, because we're going to get rid of the 300 and then get rid of the base of square root of 1/2. Alright, so let's begin that process. Okay, I'm going to divide everything by 300. And I'll get 1/3 equals the square root of 1/2 raised to the t. To get rid of the 1/2, I'm going to change this to a logarithm. So log base square root of 1/2 of 1/3 equals t. Alright, so this will find t for us. Now, I'm going to use one more formula because we don't have a base on the calculator for this. So I'm going to change that base to an e. So this will be a natural log of 1/3 divided by a natural log of the square root of 1/2. And this will be the change of base formula for logarithms. Oops, sorry. This will be the change of base formula for logarithms. Alright, so let's put all that into the calculator. Let's clear that. So natural log of 1 divided by 3 divided by the natural log of the square root, which is second function root, and then 1 divided by 2, close the half, and then close the root. And what we get here is 3.1, about 7 hours. Okay. So about a little over 3 hours, we'll have it down to about 100. Okay, number 59. A radioactive element starts with 1 gram and 2 days later decays down to 0.7 grams. What's the half-life? Half-life simply is the amount of time that it takes to get to half of its value. So if we use the general form, y equals a b to the x, we can use x is the time and the y is the amount. So the amount equals a b to the time. So the question is, how long does it take to get the a down to half of a? So a gets down to half of a. Okay. All right, the points. Okay, we know that. I may not use this. Let me just use the original. Do the original what we were doing before. Let's see. Radioactive element starts at 1 gram, so that's the amount, the output. 2 days later, it becomes 0.7. So there's the 0.7. And this is 0 time. And 2 days later, this time, we get this amount. Okay. And again, I'm going to use this right here, just to start off with, rather than using this one. Okay. Let's see. 1 is the output, equals a b to the 0. And what we have is 1 equals a times 1, which is a is 1. Over here we have y is 0.07, a is 1, there's b, and there's to the second power. I'm sorry, that's b. I wrote 2 instead. So this will be 0.07 equals b to the second power. Take the square root of both sides, and we get the square root of 0.07 equals b. Okay, so that's our b. And let's lift that up a little bit. So we got a and our b. And so the amount equals 1 times the square root of 0.07, all raised to the time. Okay, now what I'm trying to get to is a half of the amount. So if we're starting off with 1, we want to go to a half and find out what time it takes to go from 1 to a half. So let's find the half-life. I don't have to divide by 1, but I can go ahead and, let's see, convert this over to an exponential. Sorry, to a logarithm. So let's do that. So this would be a log base square root of 0.7. That's of 1/2 equals time. Okay, then we're going to do the change of base formula, which is natural log of 1/2 divided by natural log of the square root of 0.7. And that'll be our time. So natural log of 1 divided by 2, close parenthesis, divided by natural log again of the square root of 0.7, close that parenthesis, close the last parenthesis, and the time is going to be 3.88, so let's make that 3.89. So in close to 4 hours, or 4 days, should I say, 4 days, this will be down to half.